Everybody. We're going to talk a little bit more about constant and proportionality. In 1972, the federal government passed Title IX, which is a law requiring any educational institution that receives federal funds, which most do, to provide equitable athletic opportunities for boys and girls. So one of the requirements for compliance with Title IX is for institutions to provide opportunities for each gender that are proportional to their enrollment, which means they should be proportional to how many girls or boys are in the school. Okay. And then similar male and female athletes are to receive athletic scholarship dollars proportional to their participation. So that means for every dollar that a university gives a male scholarship athlete, they have to allocate at least $1 for a female scholarship athlete and vice versa. All right. So let's think about the implications at Title IX at Vista Middle School. There are 5 for every 6 boys. 5 girls for every 6 boys. So now we're going to set up proportions to solve each of these equations. So my first proportion is going to be 5 to 6. Okay. 5 girls to 6 boys. So that's going to be proportional to how many girls if there's 300 boys. So I'm going to go ahead and use a fraction for this. Sorry, that was out of view there. 5 for every 6 boys is proportional to how many girls if there are 300 boys. I use the fraction form for this. So I'm trying to figure out the total number of girls, G, if there are 300 boys. One thing I can do is I can go ahead and I can multiply both sides by 300 or 300 over 1. And that's going to equal 300 over 1 times G over 300. Okay, these cancel out, which leaves me G. All right, this leaves me 1,500 over 6. Okay, because I multiplied 5 times 300, 6 times 1. Now I can just figure out how many 6s are in here. All right. And I know if I use long division, it's a good example of making sure we keep those long division skills up. Here's a good problem. Don't pull out your calculator. So there's 2 6s and 15. Gives me 12, 3 left over. I drop down a 0 from here. And now I'm asking how many 6s and 30. That's 5. Gives me 30, which gives me 0. Drop down another 0. There are no 6s in 0. So the answer is 250. So G equals 250, which equals G. So if there are 300 boys and the ratio is 5 to 6, there are 250 girls. Okay. Now, there's 325 girls with our same 5 to 6 ratio. Now we have to solve for B. Okay. So we're going to do a very similar setup on the problem. Right now, I'm going to go ahead and divide both sides by 325 over 1. Okay. Or divide both sides by 325, right? So that's like multiplying. That's an equivalent to multiplying by 1 over 325. Okay. That's our way to handle that portion of it, right? So then 300, I'm sorry. So then we have 5, 6 times 1 over 325. Okay. Like that. All right. So now this equals 1 over B because the 325s cancel out. 325 times 6, I could do it just by doing my 25s. That's 150. And 6 times 300 is 1,800. So that would give me 1,950. 5 divided by that. Okay. Now, here's the thing. We want to solve for B. So now we have to flip B and flip this equation. So this is an equivalent to B equals 1,950 over 5. And then we could use long division again here. Do it right over here, 1,950. This is a great way to practice your long division, you guys. There's 3 5s in 19. That gives us 15. 4 left over. Drop the 5. How many 5s in 45? It's 9. Gives me 45. 0. Drop down the other 0. How many 5s in 0? The answer is 0. And B equals 390. So that's a great way to use fractions to solve for ratios. Okay. Now, what is define the variables for the quantities that are changing in the situation. For situation A, we know that we have B is boys. So the number that's changing is girls. And then we know that we have girls in B, so boys are changing. We're solving for boys. Sorry, this video went a little bit long, but I want you guys to do the same thing. All right, I want you guys to use this information that we just went over to answer problems 3, 4A, B, and C. The next video will have the answers.